My name is Wolfgang Goerlich. What we're talking about today is securing the development lifecycle, right? How does code get created? How does code get broke? Why does it matter? And what can we do about it? This is a topic that's actually very near and dear to my heart. I came out of a development background. I managed a development team for a while at a financial services firm. And I've been thinking for many, many years, how can we make our developers better, smarter, stronger, more resilient? And also in the community space, how can we bridge the gap between the hackers who are breaking things and the developers who are building things? To that end, I'm involved with the OWASP Detroit chapter and the Converge Detroit conference, which brings together a DevOps group of developers and IT ops folks with hackers to say, hey, what's the emerging threats? What's the real threat? What can we do about it? This is a very important topic to me because so much of our lives today run on code, right? The whole world runs on code. And of course, we're on business, so we know what we're trying to do. We want to enhance our security posture, and we need to lower the application lifecycle costs. There's some very real, tangible, measurable costs associated with bad code, with breaches, with everything we hear about all the time in the news. Not only the intangibles of our brand being damaged, but real tangibles that occur when we have to report things, we have to fix things, we have to get code out to our subscribers, all our users, to address these issues. So to cover this space, we're going to be looking at today as an agenda is a development framework for producing clean code and for improving our maturity around the security model. We're going to talk about, hey, why do we build apps and how do we protect the value and what are the criminals doing to drain off that value? And then we're going to show how to create a roadmap to improve the maturity. And finally, this is my favorite part because this is one of the things that people ask me all the time, right? Hey, Wolf, tell me a good war story. Tell me a good time where things looked great and they fell apart, right? What are the roadblocks? This all sounds good in theory. Yeah, we're going to build a maturity model, but what really happens when you try and do this? What do you run into? So we're going to round out the half hour looking at roadblocks and ways to avoid them. Before I even dig in, I always like to start off with the why. Why is code such a problem? And why are we having this webinar? And why is it necessary to fix this very real problem? I tell you, at CBI, we've been doing assessments for years, right? 15 years plus. And in this day and age, businesses have gotten pretty good, right? They've got some hardened firewalls. They've got some hardened servers, right? We understand DMZs. If you look at external pen tests today, you're not going to break in the same way you did 5-10 years ago. Likewise, though, just because those things are in place, we don't roll up and go home, right? And neither do the criminals. They don't go, oh, geez, these guys remembered to put a firewall in place. I'm done. I'm out of here. No, the criminals are still coming at us, and they've simply moved up the stack. This number comes from HP. The number is 84, and what 84 is the number of breaches that occur at the application layer. 84%, right? They don't go after the firewalls. They don't go after the hardened servers. They go in through those web apps. They go in through the mobile apps. And why? Because that's where the weaknesses are. We've been producing bad code for a very long time. We've gotten very good at producing very bad code, and now we're getting even better at distributing this bad code to all sorts of devices all over the place. And that is the vector, because if you can break into the code, oftentimes you can hop and break into the database, and what's in the database? PHI, payment information, health information, all the type of valuable things that they want to gain access to so that they can sell it on the black market. So with that in mind, why protect apps? Because apps are where we're getting breached. And why are we getting breached there? Because apps are where the data is. Let's talk about how we can create a maturity model to firm up our development process. The maturity model that I'm going to cover today comes from OWASP. I mentioned earlier being involved with OWASP Detroit, great organization if you're not involved with it, OWASP in general, or Detroit in particular. The software assurance maturity model covers 4 business functions, everything from governance of your development program, your construction development itself, verification and QA, and deployment and maintenance of that application over the long tail once it's out in the field. Each one of these business processes has several security functions. So for governance, you're looking at your strategy, your metrics, how you're measuring clean code, how you're tracking defect density, how you're getting that information back to your developers so you can do education, what have you. And education is, of course, so vital to the entire process because without it, we're going to continue to make the same mistake over and over again. Construction, of course, how you produce your code. Are you doing threat assessments? Are you doing threat modeling? Do you know the ways that criminals break in? And are we looking for those paths into the application, through the application to the data, so that we can build the right controls along those paths to stop the intruders? Those bubble up into security requirements, right alongside functional requirements. And of course, are mapped to a secure architecture. Because not only are things like code level vulnerabilities, SQL injection, cross-scripting, what have you, a way attackers get in, but also the architecture, right, the authentication models, the logging models, right, are ways that attackers use and misuse to circumvent our controls. Once the code is produced, that's where we get into verification. That's where we're looking at things like reviewing the design, reviewing the code using automated tools such as static analysis, Fortify comes to mind, doing security testing, right? Application penetration testing. You're bringing the guys who are going to break into apps and execute on those earlier discussed threat models. Now, we built our code, we verified our code, we put the code out in the world, and now that code is going to be attacked day in and day out. So that's what we're looking at logging. We're looking at hardening the environment and maintaining the modules that our code relies on. Because when I say 84% of all these breaches are occurring on the code level, this doesn't mean my code level or your code level. That's oftentimes the underlying modules that we all bring in, right? OpenSSL comes to mind, any type of modules that we're reliant upon. With that in mind, for business functions, several security processes, we can look at a maturity model, right? We can get the cape, we can wear the cape, we can fly, we can look at ways that we can make our security team and developers the heroes by improving our maturity. Sam also lays this out pretty well, pretty clearly. Each one of the security practices, this particular one that's on the screen right now is security metrics. Each one of these security practices has several questions that map to maturity level 1, get your cape, maturity level 2, wear your cape, or maturity level 3, you're flying. So you can go through, I'm not going to go through all of them, download the PDF, you can take a look at what maturity means at each one of these levels. All right, so this gives us a very good framework that we can then layer on top of and use to align our own development practices to make sure that we've got the right things in place to produce and maintain secure applications. But of course, you do the math, you're like, wait a minute. We got 4 business functions, we got 3 practice areas, and we got 36 levels of maturity. So you basically got 36, right, areas now that you got to keep track of. And you don't want to just dump all these on the developers, right? We see this all the time. We just go, oh, here's 36 ways that we're going to be better. Go. Clearly, we don't want to inundate the process. And to step back before I even get into how we would go ahead and push these out, I want to hit the button, the pause button, just a moment and say, hey, why are we even building applications, right? Why does it even matter that we're creating this code? When I was at the financial services firm and I was managing the dev team, it was pretty simple to me why we're doing this. We're a money management firm, and the way money management firms compete is, trading and beating the market. And the way that works at an application level is you've got applications that create predictive models, right? So you dump all this data into these applications, it crunches the data, it does analytics, statistics, what have you, it produces reports, it gets feeds out to the other systems downstream, it informs the right people so that people can then make intelligent decisions and act on them, right? That was how we were competitive. That was how we were achieving the mission of the organization, which was to beat the market and generate value. Every time we're building these business apps, we're doing them to generate some business value. And I sometimes get concerned from a security perspective that we may lose sight of that, right? So what are some of the ways that we're creating business value? What could be things like reaching existing and new customers on their mobile devices. If you ever see me and I'm not in a meeting or I'm not, hands on a keyboard, doing an assessment or doing some work, I'm on my phone. I'm on my phone like 24/7. Walking, checking in, doing things. Everything is on my phone these days, and so much of us are. I mean, my kids are even worse. So everything is on the mobile. So we're pushing more and more things to the mobile so that we can engage customers, have a higher level of engagement, deliver some value to them. And of course, along with these mobile devices and the whole plethora of other devices we have, from tablets to what have you, we got this whole ecosystem. So we're trying to connect it up, right? So I'm thinking about like the connected car, the connected home. So now we're not only having all these mobile devices and all these other devices, but we're plugging them all together. And then finally, a way that most organizations are creating value today with code is taking their existing product categories and creating new product categories, right? By internet enabling them and by plugging them in, putting in some more code. And now our fridge is online. Our soccer ball is doing data analytics. And neither of these are hypothetical. I was at a conference and the guy's like, yeah, go check out my blog. You'll like it. I'm like, yeah, I definitely will. I'm like, what are you hosting on? I'm hosting on my fridge. Pardon me? Yeah, it's on my fridge. I figured why I need a server. I already have a server. I just loaded up WordPress on my fridge. That is phenomenal. Your fridge is your web server. That's awesome. Soccer ball the same way, right? So one of the gentlemen that I work with here at CBI, his kids are into soccer. They've got a soccer ball now that's like a Fitbit that when you kick it, it gives real-time analytics back to your mobile phone. This is a crazy fun time we live in. Maybe not like Back to the Future fun time, but crazy fun time. And of course, not only is it interesting for us, it's also interesting for the criminals. So we're starting to see a lot of attacks happening on the mobile application space, right? So common errors around authentication, access control, and confidentiality in web apps, which are about 86% of all web apps are affected. We're seeing 97% of mobile, right? Because mobile is being rushed to market, and we're not putting it through the same level of testing. Also, with these mobile applications, we're seeing that data is not being encrypted. So if you look at the slides, it's about 80% that the data is, or 66% of the data is not being encrypted, which means about 80% of the time it unintentionally reveals all sorts of information to attackers. And a third of them, too, these applications, when broken, are relying on geolocation. So not only are we opening up our users to potential digital attacks, right, but also potential physical attacks. So some scary things there, and scary things, too, on the connected device side. More and more developers getting into this, more and more developers approaching it. 70% of them are working on it right now, so 1 in 5 developers are working on connected apps. And what does that mean? We're taking all this bad code on all these bad devices, and now we're opening up ourselves to man-in-the-middle attacks, communication attacks, everything else. And of course, IoT is huge, and we're seeing the same problem in that space. We take code, you ship it on a device, you no longer have physical control of that device, and now you send those devices everywhere where it's very difficult to update them. And if you're a classically trained security professional, you may remember like the physical controls is like the #1 thing, right? If you do not have control of your physical device, you no longer have that device. This is like one of the top 10 rules of security that we were all brought up on in the 90s. And we've completely given up on that at IoT. We've completely given up on that in mobile, and we're just hoping. We're just hoping everything turns out all right. And also too, in terms of enabling developers, how do we enable developers to do IoT? We give them a development kit. What's in the development kit? Unpatched Linux, usually. Telnet, a bunch of management services, usually. A whole bunch of vulnerabilities, usually. A whole bunch of software defects in the supporting modules, usually. I'd encourage you to look at all the IoT research that's coming out, and so much of it is, hey, this is built in a common development platform, and we broke it this way, right? We're seeing these problems day in and day out. So if we go back to delusion or burying our developers in all these security controls, we obviously need to move them a little bit that way, right? We need to have them look at the software assurance maturity model and take on these things and grow it, but we also need to balance the costs. And one of the ways we balance those costs is by looking at the cost to remediate. The cost to remediate goes up exponentially as you go from requirements to design to coding to testing, right? So a security flaw headed off in the requirements saves you about 7 times the effort in coding. Headed off in coding saves you about anywhere from 30 to 100 times the effort in production, right? These are real world dollar impacts, real world time impacts to having a good maturity model. So we know if we can have a better maturity model, we can protect the revenue and we can reduce the remediation costs. But we also know if we put on too much, we hinder the application process and then stop our businesses from producing all these mobile apps, IoT, everything else that's driving real world value. So this is a tricky balance that security professionals find themselves in today. And really, I think that the key to keeping a clear-eyed view of this is to remember why we're here, right? Why are we here? We're here to secure the organization's ability to achieve its mission by protecting the operational capability of the technologies that enable that mission. Why are we here? We're here to find ways that we can reduce those costs, reduce the flaws, and do so in a way that does not reduce our organization's ability to capitalize on these great advancements that are going on. It's very, very tricky. So let's talk a little bit about roadmaps and how we can start taking this wealth of information, applying it. Of course, it starts with a gap assessment. You look at the SAM, it's got the questions, you answer the questions, you figure out where you're strong, you figure out where you're weak. It's often very interesting to me to find out why you're strong in certain areas, right? You may have a core competency in metrics, or you may have a core competency in the production of code, or maybe in the verification of code, right? You may have a couple guys who are very, very good at QA, and you can capitalize that and start building your defensive model around your staff and the team you have in place. So we take a look at where we're trying to be at, we do the gap assessment, we lay out everything we need to achieve, and that's where we build the roadmap. In terms of roadmaps, that's where you're looking at ways to phase things in a logical fashion, create quick wins, create continued buy-in, and use each step of the project plan to reinforce a culture of security. So back to these 36 areas, right? 4 business functions, 3 security practices, 3 maturity levels. You take those and you lay them out in the roadmap and say, okay, how quick can we absorb this change? And that question alone bears a lot of thought. That question alone bears a lot of attention. That question alone drives a lot of what comes next, right? How much capacity does our organization have for change? Is that an hour? Can each developer like spare 1 hour for doing something new? Is that 4 hours? Is that 8? Is that 2 days? If it's 2 days, they're lying to you. No, no developer has 2 days for that much change. But somewhere in there, right? Somewhere in there is the right number. And knowing what that number is and working with the various development teams and figuring that out is instrumental in understanding what we can absorb and what we can put in place. This is instrumental in adding those quick wins and doing it in a way that shows the developers and shows the team and the organization that we're going to do this in a way that does not hinder our organization, does not slow down the development. So as we're phasing those things in, we're securing early wins. Another thing to look at is, okay, right now we know that they have 1 hour for change. We got this greenfield project, we got this new project, right? We got this new mobile initiative, we got this new website, we've got this new trading, whatever it may be. We got this new greenfield project. Let's build our timetable just a little bit longer. Let's create just a little bit more capacity, and let's use that capacity, that timetable, to implement a few more changes, right? Creating new habits. It takes a lot of time in the beginning. Maybe it is 8 hours a week, but after they've been doing it for 3 months, 6 months, that time window compresses because it just becomes a natural habit, right? It becomes part of the process. It becomes something that's executed out of muscle memory. And once it does, that 8 hours of capacity of change now shifts over to the rest of their week, and that 8 hours opens back up. So with these greenfield projects, with new projects, we can look for ways that we can ingest more change and do it in a way that's quicker and more beneficial. Sam has a great model for tracking this. Again, take a look for laying out phases and whatnot, and those phases should match up to the capacity for change and the amount of code that's being produced and the value that's on the table. When we do this, we want to align those improvements in ways that sustain and create a security culture, right? We're looking at ways that line by line of code, project by project, security process by security practice, we can shift the culture to create a culture of security, such that when we move from governance to verification, we don't have to worry about they're no longer doing governance anymore because we're not looking, right? We want to make sure that people buy into it and act on it, and it becomes muscle memory, and this is the way to do that, aligning it back up with culture. And moving forward, the way to sustain it is making sure that we're balancing those costs with remediation. All right, so that's how to produce a roadmap. All right, so let's talk about some horror stories. Let's talk about some war stories. Let's talk about roadblocks. What are some of the things that people struggle with and stumble when they are rolling out a secure development lifecycle? First thing I see, and this happens all the time, right? You gotta know if you're a security guy and you got a new tool, you got a new toy, right? You're excited, you're ready, you want to run it, you want to see what's out there, you want to get visibility, you want to play, you want to get the data, and that's awesome. Let's do that, but be careful. We don't want to bury the developers, right? So one of the most common mistakes I see is the minute you got a SaaS tool like Fortify or whatnot, you scan everything, and you're like, hey, look at this. We've got like camel case and mixed casing, and we got mixed spacing. We don't have consistent tabs, and we got SQL injection, we got cross-site scripting, blah, 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 blah. And here is all the results for all our code for all time, and it's 50,000 problems. And then you're like, oh, we'll just open up 50,000 tickets. If you're looking for a way to ensure a developer never, ever, ever wants to hear the word SAST ever again, here's a great way to do it, right? Scan everything and bury the developers. Be very careful of that roadblock. Another roadblock is comparable to this, but not on the developer side. This roadblock is on the process side, right? This is on development management. This is on the organizational side. And that's similar concept. You look at SAM, you say, hey, I want to do all this stuff, right? This is great stuff. We're going to add this, we're going to add that, we're going to add policies, we're going to add gates, we're going to add QA checks, static analysis, dynamic, everything, just throw it in there. And you do that, and all of a sudden your development process grinds to a halt, right? Because you've exceeded the amount of change that the organization can take. You've exceeded the capacity. And when you gridlock development, of course, that negatively impacts business value, and it's not very long before someone says, do we really need all this security stuff? I mean, I'm just trying to put out a mobile app. Maybe we'll just produce it and not tell the security team, right? You gotta be very, very careful to phase these things in simply. Another thing I love is red light, green light, right? Getting false positives, right? Is this false positive? Is it really a false positive? When I rolled out my development life cycle at the financial services firm, I took a very strong stance on this. Every false positive is a true result, right? If you're writing code that resembles bad code, and we've already agreed that we all don't necessarily know what bad code looks like at this point, which is why we're putting in place a security program. If you write code that looks like bad code, it is not a false positive, it's a true result, fix it. That's kind of a hard stance, and I'm not encouraging you to do that, but you have to be very wary of the opposite, which is, wait, is this a false positive? Why don't we pen test it, right? Why don't we test it? Because if you pen test every single result and get into a debate whether or not it's a false positive, you lose the efficiencies of your automated tools, your static analysis and dynamic analysis. Those efficiencies of those tools are immediately gone. and you effectively gridlock not the development process, but the testing process, right? Because they're testing everything. So you need to know how you're going to handle false positives. I like the fact of just saying there are no false positives, but there may very well be a category that applies to all your code. Another roadblock we see all the time is not addressing the underlying symptoms. So I was working with this one development lifecycle, and every time they're tested, they'd have the same 3 or 4 errors every single time, and they'd fix them, which is great. You put in a ticket, it would be fixed, life is good. And then we retest a new application, same 3 or 4 errors, exact same errors, and they'd fix them, and we go, hey, and again and again and again. And what it ended up being was that their version of Stack Overflow, right, their internal wiki for code had these errors. It said, here's how you produce code, here's how you do it, and there was a known problem, and that problem replicated to every single environment. So another way to run into a roadblock is not looking for the underlying causes, right? What is driving this behavior, and not providing the education to address those causes early on in the process. And education really is key. Developers do some phenomenal things. They create some awesome projects. But the reality is that the way they're taught produces bad code, right? Or we wouldn't see it. Bad code is everywhere. When I went to school as a developer, everything I was taught had buffer overflows. When I was, Googling to put together a slide deck, like the first page of Google results had this image. And if you're a pen tester, you see pretty quickly, that's got SQL injection in it, right? Everything we do is fraught with errors, and this is how we teach developers. We need to get more drivers training. We need to get early on in the process and address the problem at the core. Another roadblock we often see is the graybeard, is the silverback gorilla, is the developer who wrote the code and has been doing it this way forever. What do you mean it's the wrong way? You gotta watch out for those guys. And one of the things I see in terms of roadblocks is security people, because it is a curmudgeon, right? You don't want to call their baby or car ugly, right? We don't want to deal with them too much. We'll try and skirt it. And then what happens is he continues updating the wiki, he continues writing this critical code, and everyone follows him. Key thing with these guys is spend your time, spend your political capital winning these guys over. They've got a desire to write good, clean code. They are, experts in their own way. And if you win them over, you will very quickly win over the rest of the developers who listen to them. All right, one more roadblock. The jalopy, the legacy code, the code that no one maintains, the code that is owned by John, who learned from Steve, who learned from Frank, who learned from Sally, who learned from some other guy who we don't remember, who learned from the other guy who we think wrote it in the 90s. That code, right? We all have this code buried in the bowels of our system. And one of the things I've seen people make mistakes on is, hey, I've got this new development lifecycle. This code's everywhere. It's got a vulnerability. We need to fix it. And they, force a change, and that code breaks tons of stuff downstream. So be very careful of the old code, the code that no one understands, that isn't documented, that isn't owned, right? And think about other controls you can put in place. Web application firewalls, controls further upstream, and code that is well maintained. Don't touch this code if you can help it, because this will spend so much of your time, your effort, and waste so much political capital when you grind development to a halt. So those are the roadblocks that we see often. Remediating code with controls at the wrong level, losing buy-in from key developers, not addressing the underlying causes, but instead focusing on the symptoms, worrying about false positives and getting into debates about what's false positive and what's not balancing security costs with revenue, and trying to change too much too quickly. Right? We need to change at the capacity the organization can, and we need to apply security in a way that does show a cost benefit. So let's wrap up this webinar. We're just about at the bottom of the hour. We've been talking about security development today. I mentioned that 84% of all breaches are occurring at the application layer. Applications are where data is. Applications are run the world. Applications are what we live on, what we play with. They're everywhere now. Everything from, fridges, couch, blah, blah, blah. You get it. You get it. You know you get it. I get it. We're producing code, and we're producing code in the same way that we have forever, and it's a bad way, right? It produces lots of errors, and these errors and the cost to correct these errors goes up over time. Everything from requirements to development, and by the time that code's on 1 million devices across the world, we're talking anywhere from 30 to 100 times the cost to fix the vulnerabilities. The way to avoid these costs is by having a good maturity model. I showed you SAM today. You can download it from OWASP. It's readily available. It has 4 business functions, several security practices that details how to produce clean and consistent code. When deployed in a lifecycle, right, you're gathering requirements, you're doing your threat modeling, you're reviewing the architecture. As you're developing, you're doing static analysis, perhaps with something like HP Fortify, where you're checking the code, looking for known vulnerabilities, and you're remediating as quick as possible to the developers who's working, right? That's where the cost is low, because it's still in their mind, they can still fix it. When you do verification as part of QA, you're running static analysis again. You're looking at dynamic analysis, running scanners against installed operating applications, looking for known weaknesses. And once you've ruled out as much of the automated vulnerabilities as possible, you engage an application pen tester, right? So once Fortify's ran, once Web's Inspects ran, you talk to someone who can do an application pen test, someone like CBI, who will break into that application and look for weaknesses that those tools might have missed. From there, again, you remediate. You fix the problems as close as possible early on in the process so the costs are low. Then you deploy it. You continue running dynamic tests such that when new vulnerabilities are found, they can be remediated and they can be addressed. You wrap around application firewall with it, you monitor it, and you do instrumentation back to your SOC so they know how to respond. This is a full SDLC. Of course, everyone's SDLC is different. Your SDLC is different. My SDLC was different. But here's where the various tools would fall, and here's where the various business functions would play out. If you want to talk further about this webinar or your development lifecycle in particular, and figure out ways that you can do that balance of costing and implement a maturity model that will drive up your process without swamping the capacity of your developers, hey, drop us an email. We're at CBI Security Strategists at cbihome.com. Also, if you go to the website, cbihome.com, that's where we've got other webinars around similar IT risk management processes. Okay, I really appreciate you spending the time with me today. I hope this was informative. Like I said, drop us an email anytime, and I will catch you on the next webinar. Thank you very much.